This is John Black, Secret Chemist. We're here to talk about how to make a carbonate. It's pretty easy. You just take the hydroxide and bubble CO2 through it while it's in aqueous solution. Meaning that if you want potassium carbonate, then you get potassium hydroxide and you bubble CO2 through it while it's in water. If you want calcium carbonate, then you get calcium hydroxide, put it in some water, and bubble carbon dioxide through it. CO2 and H2O make carbonic acid, right? And if you have a hydroxide's a base and a carbonic acid's an acid and a base make salt water. So look at these examples. I got potassium hydroxide here. If I bubbled CO2 through, put it in water and bubble CO2 through the water, I'd make carbonic acid, and then would react to make salt water. It would be potassium carbonate. If I had calcium hydroxide, I put it in water, I bubble CO2 through it to make my carbonic acid. It reacts, makes salt water, calcium carbonate, and water. Now what I do, because I actually buy potassium hydroxide that's already in water, so I want to, when I buy it, I put it in a tray and I want to recrystallize it because it's soluble in water. But I don't like to do it fast. I just basically put it in a glass pan and throw it on my radiator, you know, my heater in my house. I have hot water. So it takes time for that to evaporate, and during that time that it evaporates, you know, it's so long that it's heating up and down. You got carbon dioxide going in and out of that solution, you know, might take a week. That stuff is already, I don't even have to bubble any CO2 in. Just the CO2 from the air did the job. Now potassium and sodium hydroxide, they're soluble. All the other hydroxides are either slightly soluble or almost insoluble, if not insoluble. So let's use calcium hydroxide as an example. Okay, so let's go down to the next example with the calcium hydroxide. You know, all hydroxides except for potassium and sodium, I can't buy at the store. You know what I mean? I have to make it. And the way I make it is to mix it with sodium hydroxide, because most hydroxides are insoluble except for potassium and sodium. So I mix them together. This precipitates out as my hydroxide, and then but there's impurities. The salt, you know, because you're going to have sodium chloride now. So I need to get rid of the sodium chloride, right? Okay, so what I do is I put it in a bigger container, right? I just mixed those two together. Here's my precip down at the bottom, my hydroxide I just made. And the rest, and I fill that container all the way up, a big container, with water. Now the sodium chloride, or whatever salt is left, it'll distribute itself evenly throughout that entire water, right? I wait, and my precip will fall to the bottom. And if you look, here's the bottom, here's the top. 75% of that, if I suck that out with the siphon or, you know, like a turkey baster or whatever, I can get it all, you know, 75% or more of that water out. If you think about it, let's say even you have 100 grams of salt in there that you want to get rid of. One wash, and you'll be down to 25 grams. 2 washes down to 6. 4 washes down to 0.1. And that's out of the whole, you know, if you're only making a little bit, then you'd have smaller numbers. But if you're making a lot, to have 0.1 or 0.3 or even 1 gram, that goes, you know, it'll be an impurity, but, you know, 0.3 grams out of this, you know, this might be 500 grams of stuff. That's nothing, man, to have 0.1 gram, because that's divided evenly among the 500 grams or 100 grams or whatever you got in there of your hydroxide. So I fill that up and I siphon it out, fill it up, siphon it out. I do that like 5 or 6 times, or how many times I want. And during that time, because it takes so long for it to settle, the carbon dioxide goes in and out of the water, and it basically just makes the H2CO3 and converts the hydroxide to the carbonate by the time I'm done, right? Now when I get done doing this 5 or 6 times, I'll let this be wet, and I will just throw it in the oven, or put it on a radiator or whatever, and dry it up. But keep in mind, if you're a real scientist, whatever you want to do it the real scientific way, you bubble the CO2 through just to make sure. You know what I mean? It depends. I mean, when I do make a hydroxide, so I want to make a carbonate, it takes me weeks. I let it sit there, and I'm doing other experiments and stuff. You know what I mean? If you're the type of person that does it all in a couple hours, yeah, you're gonna have some hydroxide in there. You know what I mean? You're gonna have to bubble some CO2 in there, and let it react with the acid that you're making, that carbonic acid. But if you're like me, you're lazy, or you're doing several experiments at once, and you just put it aside, let it sit there. I do that thing where you drain the water 6 times, right? 6 or 7 times, 5, 6, 7 times. Let the stuff settle to the bottom. I may let it sit there each one of those 6 times that I do it. It might be a day, so it might be a week later before I'm even done. You know what I mean? Sometimes it'll sit there for a couple days just on one time because I get busy. You know what I mean? Now, if you want to make absolutely sure that you have all carbonate, when you get done, you should take your hydroxide carbonate salt there that you made. It might still have some hydroxide in it. You should throw it in some water and bubble some CO2 in there, make some carbonic acid, just to make sure everything reacted. Now, when I make potassium carbonate, I buy the hydroxide. It's already in the water. Now, the reason why I don't do it fast when I do that, when you heat up a hydroxide in glass, it will frost your glass, okay? So if I take sodium hydroxide and I heat it up, or put potassium hydroxide and I heat it up, in water, it'll frost my glass. It'll change it from clear to like a frosty. It'll mess it up a little bit. I don't like that on the glass, and that's why I always do it slow, because I don't want that frost on my glass. You know what I mean? I don't want it permanently frosted. And that's basically it, how you make a carbonate. Always remember, science is great.